this first, sorry.
No, you're good.
And get rid of that.
Mm-hmm.
And so let's draw our circle.
Okay.
It has 3 chords.
Mm-hmm.
Now, that is a triangle that is inscribed in a circle.
Yeah.
And there's a formula that says that if I extend the perpendicular bisectors, they will intersect at the center of the circle.
Okay.
Okay? So, that's the theory. Let me get some, you're going to have to give me those equations again.
Yeah, I got you.
What are they? What's the
and yeah, the first one.
We did the 2 chords that were closest to the diameter. But it doesn't really matter as long as you have two out of 3.
Right, right. So for the first equation, it is y equals 4x plus 18. And then the second one was y equals 6 over 23x minus 269 over 46.
Nice numbers you picked.
I know, right? Oh my gosh. These are brutal.
How did we end up with that?
That's a good question.
That's what you get when you pick random numbers.
Yeah, I guess so.
Okay, so if we want to find where these 2 lines intersect, in other words, that's the one on the left is the one perpendicular bisector, and that's another one. So wherever they intersect is the x-coordinate of the center. Okay. And then we're going to substitute the x-coordinate into this simple one over here on the left to get what the y-coordinate is.
Okay.
Okay. So first of all, how do we solve for x?
Well,
knowing that they intersect at the center and we're trying to figure out the center, how do we make these 2 things intersect algebraically? I know how we do it graphically. I just drew it. But how do you do it algebraically?
Algebraically, isn't there an equation that goes along with trying to find the center of a circle?
No. What you do is you set that one equal to that one. In other words, when you set the equation of one line equal to the equation of another, it always gives you where they intersect. That is one method of solving simultaneous equations. In other words, you have substitution, you have elimination, and you have graphing. And graphing gives you the solution because where they intersect is the center. So first of all, let's let that.
It's going to be a nasty number.
Yes, it is. Equal this. That's okay. We can. You got a calculator?
I do, yeah. I'll plug that in.
What we want to do as a very first step here. It's an interesting equation to try to solve, actually. This actually will demonstrate your algebra skills. What have I always told you? The 2 things that I like getting rid of first in any equation?
The variables.
No, you can't get rid of the variable. You're trying to isolate and end up the last line is going to be x equals something.
Okay.
What I want to get rid of is denominators.
Oh, that's right. Okay.
Okay. In other words, this is a very messy fraction. But if I can get rid of both denominators in one step, it's going to clean it up a lot. What do I have to multiply both sides of the equation by in order to get rid of both denominators on the right side?
On the right side, well, just trying to think.
How are 23 and 46 related?
Yeah.
How are they related?
Oh, 23 times 2 is equal to 46.
Okay. So what if we multiplied everything by 46?
Okay. Then that'll get rid of
Watch
the
what
denominator.
happens. That'll get rid of both of them. You don't want to get rid of just one. In other words, if we're going to do this in one step, then we want to get rid of both of them.
Okay.
Okay. So multiply, well, I guess I can do that in my head. That is 184x. What's 46 plus 18?
Let me do it here.
Excuse me, 46 times plus 18.
Yeah, I got it. What the heck? So my calculator, man, I swear. Times 18. 828.
And now, when you do this one, what do you want to do first? You don't want to multiply 46 times 6.
No.
What, you divide 46 by 23?
You can do that.
Okay, that turns that into a 2.
Yep.
Turns the 23 into a 1. That's why we wanted to multiply everything by 46. So that all becomes 12x. And over here, the 46's cancel out, and you're left with just that. Now, that is not so ugly, right?
No, that's much better.
Yeah.
Yeah.
So if I solve for x, I get 172x equals minus 1,097. I think I did my math right.
Yes.
1,000, yes, 97. Now divide 1,097 by 172.
I got negative 6.378.
Negative 6.378. Okay. That's the x-coordinate of the center of the circle.
Cool.
Now, where's the y-coordinate?
So you would just plug that into one of the equations.
Which one?
Let's do the first one. It's easier.
Easier equation. Absolutely. You don't utilize, well, you're still going to need your calculator, but so what's y equal to?
Y is equal to 4 times 6.378.
Negative. Make sure you put a negative sign in front of it.
Yeah.
Now you're going to add 18. Okay. What do you get?
So hold on.
You get minus 6 and change, maybe 7 and change.
Yeah, minus 7.5.
Minus 7.5. A whole number? A round number like that?
It's 7.512.
Oh, okay. I was going to say, it's surprising when everything else is an irrational solution. But,
right.
So, there's your center in the third quadrant, which is where we knew it would be.
Cool. Okay.
From our drawing of the circle, you can tell that the perpendicular bisectors, when you extend them, are going to hit the center of that circle in the third quadrant. Explain how you found the center of the circle.
So I combine the two equations to find x.
You combine them. You equate them.
Yeah.
You let one of the equation of the perpendicular bisector equal the other equation of the perpendicular bisector, knowing that from geometry they are going to intersect at the center of the circle.
Okay.
However you want to summarize that.
Okay.
But that's essentially what you do. Explain
Okay.
and find the radius of the circle. Okay. You got this all written down?
Yeah.
Because I'm going to lose it here when I go to write the rest of this.
Okay.
In other words, that's I got to do something here to change this. So what was the center of the circle again? Minus
3-7.
We'll just do it to 2 decimal places.
Yeah,
And
that's what I did.
minus 7.51.
Exactly. Yeah.
Well, give me a point on the circumference of the circle. And the distance between the center and the point that's on the circumference is going to be the radius. So pick any of your 3 points. All 3 of your points are on the circumference of the circle, correct?
Uh-huh. Well, let's do the easiest one, 6-8.
Okay, I agree. 6-8. So now we need the distance formula.
Yeah. Oh, I remember this.
Okay,
So it's
what's the distance formula?
so it'd be x minus 6 squared
Come on,
plus.
give me the general. I always like to hear the general.
Sure. It would be x minus h.
X sub 1 minus x sub 2
Uh-huh.
squared.
Yeah.
Plus, you were doing it right when you gave it to me, but I wanted to make sure you knew the general. In other words, you should know the general on all of these formulas.
Yeah, for sure.
And here's the thing with these, the distance formula, doesn't matter what order you put them in.
Okay.
Because if I switch the order, it just changes the negative sign, and I'm squaring it anyway. So
Right.
the order is unimportant. So,
Okay.
okay, so you had it right. It's the square root of, and now we just fill in everything. That's why it's a thing of beauty writing the general formula, because after that, the problem solves itself.
Right. Okay. Or would you use the point like you had like 6,8 instead of?
Yeah, I would have used the easiest point there was. The lowest numbers.
Cool. Just making sure.
All right. So that's going to be R.
Mm-hmm.
Explain how you found the center distance formula between two.
So that would just be the radius.
Well, it's the distance formula between the center and one of the points that you made up. The points on the circumference.
Okay. Another prime numbers, which are factors.
I heard something about prime numbers.
Oh, yeah, my brother. Oh, ouch, that hurt. Oh, just jammed my toe, that hurt.
Okay, so I guess I got this backwards here. I didn't scroll down far enough. In other words, this is actually the explanation for how we found the radius.
Right, right.
I verbally gave you the explanation as to how to find the center using the distance formula, and then find the radius, which we did. This is the radius. I got it written in the wrong spot also.
No, you're fine. I wrote it in the right spot. Okay. We're good there, yeah.
And let's go to what they're wanting next.
Okay, equation of the circle.
Equation of the circle.
Okay.
What's the general equation of a circle?
So it's x minus k squared plus y, or
H
x minus
always goes
h.
with that.
Yeah, my bad. It's x minus h squared plus and then y minus k.
Okay, and K always goes with Y.
Is equal to m squared
R
r squared
radius squared.
Mm-hmm.
Okay, so
Cool.
what are H and K?
Could we have to find the
What do they
points of
mean?
the radius, right?
What do they mean? No, what is H and K are a very specific meaning.
Okay.
They're the X and Y coordinates for the center of the circle. That's all they are.
Okay. Yeah, we set to find the center.
So we just calculated where the center was and what the radius is. So now we can fill in. What was the X coordinate of the center?
It was minus 6.37.
Okay, now if I do this the way I want to do it, minus 6.37, all of that squared, plus y minus, and this was minus 7.51, all of that squared, and that's equal, did we come up with a radius?
I'm doing it right.
Yeah, we did.
Now. Yeah.
What did we come up with?
I got 252.62. Does that sound right?
Well, is that right?
Maybe find the square root of that. Well, I put it all under.
Yeah, even that's going to be big. But go ahead and find the square root of that. Yeah, that number is way out of the realm of possibles.
Yeah, 15.89.
Okay, I could believe that, I guess. I'll trust you. I mean, I'm not checking you with the calculator here.
You're good. Yeah, I put it in just how I
If that's
wrote
the
it.
radius, then it has to be that square. That's the equation of the circle. Now, I can simplify it a little bit, but not a lot. I can turn those two negative signs into a plus. So you get this. I certainly do not want to perform that squaring. That's part of my final answer that you're looking at here. In other words, you put it in the form of a circle. You don't simplify it by multiplying stuff out.
Okay.
Except that number. Square that. Oh, you did. It's 200 and something.
0.894. Yeah, 252.619.
252.62. Okay. I like that pink on black.
Yeah, that's kind of cool, actually.
Yeah, it's like a blackboard. That's like Saul Kahn uses.
Yeah, I like that.
That is the equation of the circle.
Cool.
Okay. And the biggest mistake that I see students make is they make it equal to r instead of r squared, and then or they'll think that's r. And always remember the general equation of the circle. You can't go wrong. Because we just found the h coordinate, which is the x coordinate of the center, the k coordinate, which is the y coordinate of the center, and r. We calculated that.
Right.
This was quite a problem.
That is, man.
This was an hour-long problem. We've spent an hour on, and that's it, right? Yeah.
Yeah. That took a little while.
That's a heck of a problem. Especially when they make you pick your own 3 points. Because that virtually guarantees that you're going to be dealing with oddball numbers.
Right.
In other words, unless you happen to get extremely fortunate and but by the time you do the distance formula and those perpendicular bisectors, the numbers get all spaghettified and scrambled, which is what happens. So, yeah, you always are going to need a calculus for a problem of this nature. But I kind of like this problem. Yeah, it's clever, the fact that they didn't give you the 3 points. Because if they'd have given you 3 points, they'd have made the numbers such that it would have made it an easier problem.
Right.
You know what I'm saying? In other words,
Yeah.
one could find 3 points where the math wasn't quite as crazy as it was for us, but
Right.
only if you kind of knew them in advance. And that's what they would typically do, is give you 3 points that are still on the circle, but the math turns easier.
Uh-huh. Cool.
Anything else tonight, Dylan?
That's it, honestly.
Okay, cool.
Yeah, that was awesome. That was
That,
real good. It's a
that was an
I guess
awesome
it's a
problem, actually. So,
yeah.
okay, I'll talk to you
Awesome.
next time.
Sounds good. Thanks, Mr. Count. Appreciate it.
Bye bye.
All right, bye-bye.